We often picture the Big Bang as a cosmic detonation, a massive bomb hurling matter out into an empty void. But that picture is wrong. There was no blast, and there was no debris. Instead, space itself simply stretched. Every point in the universe was expanding outward in all directions at once. If we take that expansion and rewind the clock 13.8 billion years, all the matter and energy we see today gets packed into an increasingly smaller, hotter space. Push it all the way back, and our equations tell us everything compresses into a singularity, a state of zero spatial volume and infinite density. A point of infinite density defies physical reality. It marks the moment our rules of logic, reason, and general relativity cease to function. The singularity is an error message, proof that our mathematics is dysfunctional at these extreme scales. Because our calculations fail at that infinitesimally small point, the Big Bang cannot be called the absolute start of existence. It is a wall in our understanding, a boundary where our current theories stop working. To find the true origins of reality, we have to look behind the glitch and deduce the architecture that existed before the birth of the universe. In the late 1970s, the standard Big Bang model was struggling to explain why the cosmos was so uniform. Theoretical physicist Alan Guth sought to fix the glaring anomalies in our origin story. He proposed a patch called inflation. The sudden growth stopped, and the residual energy decayed, flooding the vast, empty cosmos with a shower of electrons, quarks, and photons, the raw materials of our reality. This map shows the cosmic microwave background, capturing the radiation left over from the infant universe. The modeled blue and red spots represent temperature fluctuations. Their exact statistical distribution matches the patterns predicted by Guth's inflation model. Inflation neatly patched the holes in the Big Bang math, but by solving the mechanics of our observable universe, it opened the door to a far more terrifying cosmic reality. The inflation patch creates an immediate logic problem. If a powerful quantum field initiated this hyper-fast expansion, we have to explain why it stopped at the exact right moment to create our hospitable universe. This discrepancy leads to a model called eternal inflation. In this view, once the initial scalar field triggers expansion, it never lets off the gas. The overarching growth of space doesn't stop. It is a runaway, self-perpetuating process. Within that runaway expansion, local patches of the field eventually lose energy. They pinch off and settle down into separate, self-contained pockets, while the vast space between them continues to inflate faster than the speed of light.
This means everything we see, all our stars, galaxies, and billions of light-years of space, is one isolated bubble floating inside an endlessly generating multiverse. In Fyodor Dostoevsky's novel The Double, a man encounters an exact replica of himself. In an infinite multiverse, that fiction becomes a statistical certainty. With endless bubbles, there are only so many ways to arrange atoms. Eventually, every possible combination repeats. Right now, in a distant bubble, an exact copy of you is listening to this sentence. By patching the mathematical glitch at our origin, physicists downgraded our universe to a recurring speck in a cosmic foam. This leaves us with a lingering mystery. Out of all the possibilities in that foam, why does our specific bubble have the exact right gravity, electron mass, and speed of light to allow life to form? String theory proposes that the building blocks of reality are vibrating loops of energy. To function, these loops require 10 or 11 spatial dimensions, most of them curled up on themselves at microscopic scales. These extra dimensions can fold in 10 to the power of 500 different ways, each dictating a different set of physical laws. The multiverse provides a physical testing ground for this math. Each new bubble universe settles into a different configuration of those extra dimensions. They fall into different valleys on a vast topological map known as the string landscape, each operating under entirely distinct rules. Most of those bubbles are sterile. Their laws of physics immediately rip matter apart. We find ourselves in this specific, highly tuned bubble simply because it is one of the rare configurations where observers can actually exist. Of course, the math of strings and inflation is currently untestable. If it's wrong, physicists like Roger Penrose point to alternative patches, like a cosmos that cycles through repeated Big Bangs, or higher dimensional brains colliding to spark new realities. Whether reality is built from colliding dimensions or a runaway string of infinite bubbles, these theories are architectural blueprints attempting to solve the broken math of our origin. Yet even the most complex models crash into a final wall. Eternal inflation, cyclic universes, and string landscapes all describe a sequence of events. They imply one thing happening after another, which means there must be a beginning to the clock. But time is tied directly into the fabric of space. In the extreme quantum conditions of the early cosmos, our biological understanding of past, present, and future dissolves. The rule of cause and effect loses its meaning. We want to know what existed before the Big Bang, but in a state where time itself hasn't unfolded, the word before has no physical meaning. Our conscious minds are tethered to a linear existence. We may lack the cognitive framework necessary to grasp a state of reality that doesn't operate on a timeline. While the mathematical pursuit of our origins pushes logic to its absolute edge, it leaves us with one profound mystery: why there is an ordered reality rather than absolute silent nothingness.